Okay, so welcome everyone to our next YWIB event. Thank you for tuning in to our Young Women in Bio virtual presentation. We are very excited to announce the availability of these online resources through a brand new YWIB online platform, which provides young women across the United States and Canada free access to our educational and leadership programs and other opportunities in science, technology, engineering, and mathematics. YWIB is launching this new initiative for young women who are curious about STEM, want to learn more, but may not live near one of our 13 Women in Bio chapters in cities across the United States and in Montreal. Our mission is to give girls today the inspiration and support they need to become tomorrow's leaders in science, technology, engineering, and mathematics. We strive to provide educational and hands-on experience in STEM and share our passion for all scientific fields. The launch of YWIB Online comes at a time when there is a real need to provide young women who cannot otherwise attend our events and programs with access to online programming in STEM. This will help with our goal to ignite curiosity and inspire young women to see a future for themselves in STEM. We believe that by making these online resources available to a broader audience of girls, we can encourage more young women to find a lifelong passion and careers in STEM. YWIB is part of Women in Bio, with chapters nationwide and in Canada. WIB is a nonprofit volunteer organization that promotes diversity and inclusion for women in the life sciences and beyond. We partner with leading companies and universities, hospitals, and other organizations to host highly engaging educational and motivational programs for young women interested in STEM. In fact, one year we had more than 70 events across North America, reaching more than 4,500 young women, and had the support of over 250 volunteers. Next slide. So today, Young Women in Bio-Capital Region is hosting an Oncology Educational Module for middle and high school students to gain insight into cancer, including the biology behind it and careers involved in the field. Our panelists today will present on oncology, followed by a Q&A moderated by a YWIB-Capital Ambassador. I'd like to begin by introducing Anvita Malaka, YWIB-Capital Region Ambassador for the 2020-21 school year. Anvita is a rising college freshman who's graduating from Brer Woods High School and the Academy of Science in Northern Virginia. With her passion for STEM developing at a young age, Anvita has been involved in numerous STEM activities. She served as a group leader in the FDA's Oncology Center for Excellence for Summer Scholars Program. She's the president of her school's Science National Honor Society and president of Connect for Cancer, a cancer awareness club that she co-founded in her school. Anvita has conducted independent research to further her scientific knowledge, both in cancer cells and in plants. This year, she participated in a regional science and engineering fair, where she won the first place award for her research on the effects of banana peel extract in rice water on the growth of radish plants in highly saline environments. While she is not involved in STEM activities, Anvita focuses on her other passions, the arts. She's involved in dance and music from a young age and enjoys singing, playing the guitar, and choreographing routines. In her free times, Anvita loves to spend time with her friends and family, and she's very passionate about STEM, especially cancer research, which she plans to study more in depth as she continues her education at the University of Virginia. So Anvita, I will transfer this over to you. Thank you.
Thank you. Hi, everyone. I'm really excited to moderate this event and would like to introduce our first speaker, Dr. Krystal Morales-Rivera. Dr. Morales-Rivera is a radiation oncology physician at the University of Michigan in Ann Arbor. She's training on cancer treatment with radiation therapy. She was born and raised in Puerto Rico, where she completed a bachelor's degree in chemistry at the University of Puerto Rico. Driven by her passion for science and early involvement in research, she pursued a PhD at the Biochemistry and Biophysics Department of Texas A&M University, where she utilized nuclear magnetic resonance techniques to study protein structure, dynamics, and their role in protein function. Determined to translate her research career into a clinical focus, she completed her medical degree at the University of Puerto Rico School of Medicine. Prior to starting her training in radiation oncology, she completed an internal medicine year at Mount Sinai Hospital in New York. She enjoys sports, traveling, and her biggest passion is to empower and implant the importance of education in young people. Next slide, please. And then Dr. Morales-Rivera can begin.
Thank you. Thank you for that very kind introduction. Hello, everyone. And first of all, thank you to all the organizing for the invitation. I'm very honored to be here today, part of this panel. I wanted to start with a little about me. I think some of my animations are old. Can you try to go back? I think it's not working, but it was a Google map showing the colorful island of Puerto Rico and where it was located in the Caribbean. So it was just blowing it up to show you how small we were. We're like 100 miles by 35. And within the island of Puerto Rico, I grew up in an even smaller town towards the west part of the island. It's an hour drive from the capital, San Juan, and that's actually far in our island metrics. And the picture that is showing up here is an interesting fact of my hometown, and is that the population to cows ratio is roughly 1-to-1, and it's about 30,000 people, 30,000 cows. So not too surprising to you now. I grew up in a dairy farm, milking cows, probably drove a tractor and operated heavy machinery probably since I was 11 years old. And I wish I had brought more pictures of it. It would have been more fun. Next slide, please. The reason I highlighted that my town is far by our metrics is because starting to where all of you are now, high school here on the left, not many high school graduates in my town pursue undergraduate studies overall. And the number is smaller, even smaller in science, math, and technology, engineering fields. And from those who actually pursue an undergraduate degree, an even smaller number leave my hometown to one of the two bigger undergraduate campuses that concentrate in biology and engineering, for example. So I will try to briefly summarize my training journey here. As probably many of you listening today, I'm one of those who did not have any family members growing up that were research scientists or doctors. I have an older and a younger brother. I'm middle child, but I'm the only girl. And all my family on my dad's side have been working on the dairy farm for at least the last 4 generations. On my mom's side, my grandpa was a policeman and my grandmother worked in many factories. Probably the only medicine-like background I had was that my mom did an associate degree on nursing, but she actually never practiced. But the only thing I knew is that my favorite subject in high school was science and all that biology and chemistry, and that I wanted to pursue something related to medicine. And just so you have an idea of how vague my thoughts and my plans were of what I wanted to do at that time, or at this time that you are now. I felt very unprepared filling out undergraduate college applications. The counselor of my town was even asking me why I wanted to pursue my bachelor's degree in the campus in San Juan, and away from my hometown, where there were other smaller ones that were closer. Not a lot of information from that end, and not so much experience from my family end either. but I was an A student and I knew I could have a chance of getting into one of the competitive science and engineering college that were far from my town. And that's what I wanted to do and what I felt it was going to bring me more opportunities as I move forward. While certainly family support was and still is that thing that keeps me moving forward, little my parents knew, and even less I knew when I was in high school, of all the steps that it would take to become a doctor or to become a research scientist. But they supported me. So I went to the University of Puerto Rico in San Juan, where I graduated with a major in chemistry. I believe that year in 2004, when I graduated, I was the only student from my high school that went to that campus, and there were only a handful that left the town to some of the other farther away campuses. Long story short, in this slide, I got involved in research early on, like sophomore year. I was curious about everything, pretty much getting into every opportunity I had. And I started working in a lab sophomore year for about 2 years, and went to conference as part of a federal funded program for minority students. And this really opened my eyes to kind of the many possibilities. And this is what took me first into the PhD route after graduation, where I went to A&M, where I did my PhD in biochemistry and biophysics. But I knew my first year there that I was missing that portion of my biggest passion of direct patient care. And I realized I never took the opportunity during my undergrad time to explore that. So during my PhD, I did that. I took the famous admission test called the MCAT, applied, went back home for medical school. My PhD took me about 5.5 years. And then I moved to Puerto Rico and graduated in 2018 from medical school, and I loved almost every second of it. Within the duration of all of the steps I'm showing here, what I wanted to highlight is I took every opportunity I had in hand, and all of those have contributed to where I am today. In medical school, I did a summer internship at New York City at Memorial Sloan Kettering. And this is what actually presented me with the specialty I'm pursuing today of treating cancers with radiation therapy. And if you click one more time. One back. Oh yeah, it's okay. All of this to say that I assure you that the road would not be this straight line. I tried to draw a line that was going in different places. Just to show you that the life and career journey is not a straight line, and that is okay. And as long as you keep moving towards your goal of outcompeting yourself and have fun in the process is what matters. Next slide, please. But our focus today is oncology, and what I wanted to kind of present to you guys briefly was kind of going back to the basis of what being an oncologist from a physician perspective is and what that entails, and all the branches that are possible within. As we will hear from my colleagues in the panel today, there are many more branches in the oncology field, including research, public health, epidemiology, that we could talk for hours, that you can be part of. From the clinical perspective, there are 3 main weapons. That's how I like to think about it, to treat cancer. And depending on the tumor type, meaning, for example, breast cancer, prostate cancer, lung cancer, and how advanced the cancer is, we sometimes use only one approach or a combination of these 3 main tools here: surgery, chemotherapy or systemic therapy, and radiation therapy. So first, we can remove tumors with surgery. Okay. We can kill tumors using systemic therapy or drugs that go through your entire body, either in the form of a pill, an injection, or intravenous. And this is what we typically know as chemotherapy, but now the term should really be systemic therapy, as research has unraveled a whole field of immunotherapy and many other cancer-directed therapies. And last but not least, and not to be biased, we can focally treat target tumors with radiation therapy, as I will show briefly in an example in a couple of slides. So you click at least 3 times, maybe. One month. So physicians in the oncology world who perform surgeries are surgical oncologists. Chemotherapy is administered regimens by medical oncologists, and then to deliver radiation therapy, you're a radiation oncologist. So these are kind of the 3 main branches. Next slide. So from my perspective, how radiation works, right? We as radiation oncologists, and me in training, I'm learning how to use high energy X-rays and focus them, kind of shape the radiation with special machine equipment to the tumor. We use X-rays in a similar way, used to get images in CAT scans or plain X-rays, but for radiation therapy, it's much, much higher energy. We shape the beam, thank you, we shape the beam to target the tumor. In this case, it's just a picture of a tumor within the lung, for example. And when the high energy X-rays interact with the tumor, it ionizes molecules within the tumor cells, specifically forming reactive oxygen species. These are very unstable molecules and damage the nearby DNA by inducing DNA breaks, as that is showing. And so what happens if the genetic material of a cell is broken? We lose the ability to copy the genetic material and replicate further cells, right? Now, our body has mechanisms to repair DNA damage, and normal cells are able to do so. They can fix the DNA and then they can go on and survive. However, cancer cells have an impaired ability to repair DNA damage. Reasons behind why these cells became cancerous in the first place and have this uncontrolled growth. Because they're unable to repair the DNA damage we induce with the high energy radiation, then they die because they cannot propagate. And the idea is that we preferentially damage the target cells who are unable to repair, whereas the normal cells are able to repair. Okay, so hopefully that kind of brings a perspective of how radiation works. Thank you, next slide. So a common scenario that I wanted just to bring to kind of spark your interest or curiosity about this field is the use of radiation therapy to treat brain metastases in patients where the cancer has spread from its primary site. For example, you have a cancer that's started in the lung and then traveled to the brain, and we call this metastatic disease. And I will show in a minute how a brain metastasis look on an MRI or a CAT scan, but to treat brain tumors and for every radiation therapy, we have to make sure the patient's head, in this case, are in the exact same position every day for treatment. And what I'm showing here on the left is the mask that we make. It's kind of like a material, you heat it up and then it molds to the patient's face. And that's what we use to make sure the patient is every day in the exact same position. Then we get an imaging of the brain with the mask on, of course. It's usually a CAT scan and a brain MRI. And then we use those images to design the radiation and how we're gonna kind of calculate and shape the beams to target the tumor. Next slide. So we have made the mask, got the CAT scan, got the MRI that I'm showing here, and then I get to literally paint tumors. these are different views and planes of MRIs. You can clearly distinguish here if you see where that brush is on the right, kind of how that bright area within the normal kind of gray appearance of the brain tissue looks like. And of course, I have circled these areas already. Okay, so that's what we get to do next. It's almost like using paint to draw where tumors are. Next slide, please. After this is done, a big team of physicists, treatment planning team works to aim the radiation at the areas that we drew. Pretty much it's like determine the coordinates from where the beams are going to come in and focus the high dose radiation. If you click on the next two animations, where they meet in the middle. I call it the asterisk risk, or a lot of people call it that way, because it's like an asterisk. You come from like low doses of radiation, and where they all meet in the middle is the highest intensity, and that's where you're aiming it, where the tumor is. This process takes about a week. Then the patient comes for treatment. Next slide, please. This is just, of course, a cartoon example of the treatment machine. It's like a CT scan machine, but has this big arm that moves and rotates around the patient and delivers the treatment that we design and plan for about a week. In real life, on next slide, this is how it looks. Patient has his mask on while the treatment is being delivered, and the machine moves around it. Radiation is painless. This type of radiation doesn't make you radioactive, and you can't see it, you can't smell it. It's like getting a CT scan or an X-ray, which I'm sure most of you have, okay? And then we get to see how well the radiation works in a couple of months by repeating that imaging. And this is just a very, very, very light picture of the many, many amazing things that can be done with radiation therapy. Next slide, please. Hopefully, I was able to show you a very small portion of the cool things you're able to do within the oncology field as a physician. This last slide repeat was just to bring back the main point to all of you that the road will not be a straight line. Family and people around you may not have all the answers that will help you succeed, and trust me, you will find mentors and, more importantly, role models along the way that will guide you through the process and what you want to do. And as you may know by now, achieving a career in science or anything in life, really, as a minority, as a woman, etc., you have to be proactive in the same way that all of you are being today by joining this session or listening to this session. So the most important takeaway, and cliche, but follow your goals, dreams, and passions. Don't let where you come from dictate where you want to go, and don't let language barriers limit you, and have a lot of fun along the process, because you will have fun as well. And thank you again for this invitation.
Thank you, Dr. Morales-Rivera, for that amazing presentation. Our next speaker is going to be Dr. Christopher Cross. Dr. Cross is a multidisciplinary scientist with expertise in biomedical engineering, neuroscience, population genetics, cancer biology, science policy, and nonprofit development. He's the managing director and founder of Cross River Strategies, a boutique consulting firm that specializes in advancing health equity for underrepresented and vulnerable populations across the healthcare landscape. He was recently named a principal investigator for the Community Research Fellowship Program through the Center for Community Engagement and Health Equity within Smilow Cancer Hospital and Yale Cancer Center. Dr. Cross has championed development efforts to establish the Lavender Fund at Howard University, the first official initiative to support LGBT+ students at any historically Black college or university. To date, there have been 17 scholars awarded across disciplines, including medicine, law, and dentistry. He completed his bachelor's at Georgia Institute of Technology, master's and PhD at Howard University, and postdoctoral fellowship at Yale University.
Thank you, Anwita, for that introduction. And Also, thank you, Dr. Rivera, for your excellent presentation. I mean, you spoke all about so many things that I think we've all encountered and continue to encounter. So thank you for all the work that you're doing and sharing your story. And again, thank you to the organizers for this event. So let's get started. Flip the next slide. So the title of my talk is Insights from a Cancer Researcher, talking about the past, present, and the future. And so I don't have to recap any of this, so let's go into the next slide. So this is a little blank slide because I know how it is when we're engaging in talks, so sometimes it's kind of good to have a little bit of a break. And so again, my talk is focusing on the past, present, and the future. So we're going to talk a bit about the past. How did I get to become a cancer researcher? What steps did I take, from high school, undergrad, graduate school to now, and then talk a bit about cancer, and then what are some suggestions we can all take away from some of my experiences. Next slide, please. So in this is high school. So I put an array of pictures here to kind of start to tell a story. So the upper left picture, that was my first official research experience. I think I was a junior in high school, and I don't know how I found out about this program. It was located at Indiana Tech. And so I grew up in Columbus, Ohio. And so Indiana's not that far from us. But I was at the high school I went to was called St. Charles College Preparatory School. So it's a Catholic high school, an all-boys school, known to be very rigorous in its academic efforts. And I think it was probably through one of the counselors, and they were like, "Oh, you're interested in STEM? Hey, there's a research program you should think about." So I contacted them, and that was really my first sort of official introduction into STEM research. And so what was cool about it was we ended up having to build solar cars. And so for me as an aspiring engineer, I was like, well, this sounds super cool. And so if you can kind of take a little closer look, there's like one brown face that's sticking out there on the little scaffolding there. And that was me. And I was used to being that one sort of chocolate drop in a lot of the institutions that I was a part of, even at that point. And so that was normal, right? And so for me, what was abnormal is if you see this young woman to the right, I don't remember her name, but she was there welcoming all of us into the Indiana Tech program. And I remember seeing her and I was like, oh my gosh, there's somebody who looks like me who has like, you can see like her smile. I think she was actually happy to see me too. Like, oh, there's somebody else here in this program. So I put that there because as you know, the focus is young women in bio. And for me, this talk is about even being inspired by other women who may be in bio or bio adjacent, and how we're all interconnected. And so she made this research experience more accessible for me from more of a mental psychological standpoint. And so I had this picture of her from like my Polaroids that I had saved in like a photo album. And I just remember how kind she was to me and how welcoming she made me feel in an environment where most people did not look like me in doing this research endeavor. So in the lower left there, that's giving you another insight into my high school. So the guys that are running with me on the track team, it was majority a white school. They were good guys, but at the same point, it's isolating, right? To be in certain environments where people don't necessarily look like you. And to be quite honest, during that high school, I actually experienced some overt, blatant racism around sports and in an academic setting. And so luckily my parents they were both from small towns. And so they had experienced things in their own right. And I think it was a window of, okay, this is a make or break scenario. Either I really need to show up for my son so it doesn't go to the left instead of to the right. And so luckily, my parents had my back and I ended up leaving that school. And I finished high school in Kennesaw Mountain. So basically it's the city's called Kennesaw, but it's in the greater Atlanta area in Atlanta, Georgia. And so the picture on the bottom right is my senior photo, right? Because I think that's something that high schoolers are all looking forward to. And as you know, like this is like a major moment because you've seen your parents' senior photos, you've seen your grandparents' senior photos. And so you're like, okay, I need to make sure this is like a good one. So for me, it was really exciting to kind of encapsulate, like, of course, you know, STEM can feel isolating, but there are these mentors, there are these, you know, guideposts, whether they're your parents or whether they're strangers, to support you along your path. So let's go to the next slide, please. And so now I'm in undergrad. I got into undergrad at Georgia Tech. So I was really actually at Southern Poly, and then I ended up transferring to Georgia Tech because I didn't get in the first time. That's not something I tell very often, but I think it's important for the audience here because you may not, you know, get to your dream school the first time, but there are other pathways to get where you want to go. So I didn't get in initially. So I went to a smaller school that had a good relationship with Georgia Tech. And ultimately, I killed it, right? Great grades and everything. And I had good grades to begin with, but you never know sometimes why you're not selected. And so I transferred in after my sophomore year with like a 4.0, 4.2 or something. And then endeavored into finishing at Georgia Tech. But the picture to the top left is actually my sort of second major research experience. I found on like, because the internet was like growing and growing this time. This was like 2000, I think, so I graduated high school 2004. And so this was 2007 when I went to Ireland. So that's that picture. It's at a summer program called the Eureka program that was created by the National University of Ireland in Galway. And so not only was it like my second kind of major research experience, it was abroad, right? To go all the way to Europe. And again, you can see there's another brown face further down the line, but there's not many of us. And so it was another sort of experience, right, in the same space. But I got to meet, you know, people from Ireland, from India, and some folks I think were from like Rice University in Houston, and some folks from Pittsburgh, near Philly. And so it was another major experience that science kind of gave me this gateway to meet people who didn't look like me and experience something from, you know, the other side of the world. And that research actually was focusing on skin. So we were looking at like dermal, epidermal areas to kind of figure out if there's some sort of skin adaptation there that we wanted to investigate. So I was doing like immunohistochemistry, so which is basically a staining of the tissue that pathologists look at to evaluate other abnormalities there. And so I'm sure as high school you've seen, you know, cell biology pictures. And so that's how you make those pictures, or through those techniques. And so I was doing those techniques when I was over there. And so that was really, I think, what catapulted me into being even more accepted in the Georgia Tech research community. And so it's interesting, sometimes you have to leave your home to get experience and then come back to your home, and then you're valued, and then you can kind of go on and do a lot of other things. So the next picture to the right of that is an organization called NSBE, so the National Society of Black Engineers. So I found this organization within Georgia Tech that was, okay, this is now a whole community of people who likely had similar experiences that I had. So I say that to say, like, once you're, you know, in college or even in high school, finding groups where you have things in common, you know, it's critical because they become your support system. They help you think about, you know, different ways to navigate your future that you might not think about. So that to me was major, to find that organization and, you know, in a sense, you know, a second family in ways. And then to the right of that is when I finished at Georgia Tech, and you can see my sisters all next to me. And so my sister Renee, to the far left of me, She just was named AT&T's 2021 STEM Woman of Color. So we were working together on her bio and things. And so she's a woman in STEM, and maybe next time she can talk to you guys too about her story, because it's very unique too. So anywho, finished from undergrad. And then the next picture on the lower left, if some of you knew Congressman John Lewis, he was a major civil rights leader. He walked with Dr. Martin Luther King. He's been a congressman forever. He recently passed away. But I met him during my first job. And so I was the only Black scientist, my first job. I was a junior scientist. And that's the CEO of our contract research organization. I was there. And the funny thing is, when the Congressman Lewis walked in and saw me, he was like, "Oh, I didn't expect to see you here." And I think people do that a lot, right? With when you think about a scientist, when you think about somebody in STEM, there's an image that pops up, and it's not usually, a woman in STEM, or a underrepresented person, or a Black man in STEM. So I went to Howard for my undergrad, for my master's and PhD. And then the third photo on the bottom is one of my best friends, Raji. She finished her PhD the year after me. So I finished in 2019, and then she just finished in 2020. And so again, this is somebody who I became very close with during my graduate career, who supported me in many ways as I started the Lavender Fund and things like that. And we became co-chairs. So it's just, you find these people that are part of your tribe, right? You kind of collect these people that are awesome and that you support and they support you. And so kind of full circle moment is when I was elected to be on Howard's Board of Trustees. And then Congressman Lewis was giving the convocation speech. And so I met him again. And I actually had him sign the picture on the left. So there's a little piece of his signature that's below the picture. So that's actually what I had in my hand. I was like, "Can you sign this?" From this sort of full circle moment. So let's go to the next slide, please. So this is why I titled Present-ish, because this is, so after I finished from Howard, they went on and posted a bio of me and kind of what I'm doing now and what I did while I was there. So, and as you heard Anwita talk about in my intro about starting the Lavender Fund at Howard and how we've got over 17 scholars. And so that's what the picture is below that. That's one of our annual events, because when I was on the board, we created this fundraiser. And so it's been going since 2015, once marriage equality was passed after the Supreme Court passed the Obergefell v. Hodges case. And so since then, the years have been going on and Howard's adopted it, and we have this LGBT homecoming, right? And so now, not only in my little tribe of just me by myself, there's a growing tribe, right, of a legacy that I've tried to help create there. And now there's funding that go towards individuals celebrating all of their identities. And so that's something I'm most proud of and happy that I was able to create. And then the picture in the upper right is an organization I was on the board for called OSTEM. And so they're one of the national largest orgs that help represent students, LGBT students that are in STEM across the country. And even like they had some chapters in Europe. And then the lower right is like my current life. So I have my husband and we have our daughter, Ellery, and he's in the military. He's a physician as well. He's a physician in the military, not focused on cancer. When we met, he said he was going to be an oncologist. So that's, was one of the reasons I was interested. But now he's switched and he's doing aerospace medicine. So I guess that's okay now. So yeah, let's go to the next slide. And so for me, these were sort of the tenets that I tried to, when I reflect on like what helped those things happen. And even Dr. Rivera mentioned this too, like curiosity, right? I think it all starts from this space of like, I want to figure something out. How do I figure it out? And then I put capability, and let me unpack that a little bit. That meaning, that's sort of the benefit of education to begin with. It's kind of this safe space environment to figure out what are you capable of, right? You kind of go through all of these tests and classes and you're like, what is it for? In some senses, it's almost like a little smorgasbord. Like, let me taste a little bit of math here. Let me taste some geo here. And you kind of get exposed to these different spaces and figure out what you really like, right? And then you kind of do that again at the undergraduate level. And then you sort of specialize at the graduate level. And then I will also add in discipline is a big piece, right? Unlike anybody on this panel, I know we've got Christine coming up as a patient advocate, and her story is powerful too. And it's all about finding something you're passionate about, and even when things get tough, you're still kind of pushing through with it, which is tied to drive, right? You're like, okay, I want to make this happen. I found something I'm curious about. I know what I'm capable of. I really want to do this. I'm just going to push it and just keep going. And then I think one big piece that sometimes gets left out is gratitude. And I think as you get down, you realize that all this stuff you've done, like, yes, you've been in the driver's seat, but there's been many passengers, right? There's been times you've been traveling in that car, somebody put fuel in your tank, right? Somebody sat there with you, somebody's in the car, somebody's cheering you on, somebody's got the radio turned up, you're playing your favorite song, singing it with you. So you got to have gratitude for all the folks that have been with you, right, throughout this process, and then try to give back through your research and your talents. So I know I'm like talking a lot. Let's go to the next slides. So this is present, so my cancer research. So I'm in my second year of my postdoc. We're really wrapping up. I'm really just helping with some manuscripts now. This is my boss, Dr. Jeffrey Townsend, who's been awesome. The lab focuses on molecular biology and systematic evolution of cancer. It's basically, we have a bioinformatic technique we've developed, and we can start to detect the genetic risk involved with an array of cancers. I'm focusing more on prostate, melanoma, kidney, and esophageal. We've done some breast cancer stuff as well. And then my company, CRS, my business partner, Dr. Liu, met her through my trajectory. Definitely somebody who was in my car with me at some point during my travels and now back in the car. And so we're leading our efforts there at CRS, and Joe's been awesome. And so one of the main things we've done in the company is partner with a company startup who is really on track to be the first FDA approved blood test to detect colorectal cancer. So they will detect CRC through a blood test. And so we've helped diversify their clinical trials and things like that. And then under my PI appointment through the Cancer Center and the Care Center in particular, I have two research fellows, Belinda and Taritha, who've been awesome. And they're still with me through August. And so we focus on understanding how can basically digital data of individuals. So think about like patient generated data, how that can be used in FDA submissions for cancer clinical trials. The next slide, please. So now we're getting into, I'm kind of introducing you to the work we're doing in the lab. So the molecular basis of cancer, right? So in high school, you're like, okay, I know about, cells that divide, and that's exactly what we're thinking about with cancer. So cancer is the result of gradual accumulation of many different types of genetic changes. So it's basically an accumulation of mutations that happen over time, right? And they can happen in certain areas, and they all can take sort of different pathways by which they grow. And so there are certain genes, right, that we've identified known as driver genes, meaning they're driving, the mutations to cancerous stage and then to a more detrimental stage that we more codify as a metastatic condition. So next slide, please. And so driver genes, so now we're getting a little bit deeper. We're understanding like how are these driver genes sort of codified? How are they deemed driver genes based on science? And typically they do like p-value and prevalence. And I know in high school, we know about statistics, right? P-value is one of the basic things you think about. The 0.05, what's significant, yeah? And so basically it's a little bit more sophisticated when you're dealing with mutations in cancer because the p-values can be small even though there's many samples. but essentially it's still used as a statistical test to say, hey, this gene has been connected to cancer. So it's like a yes or no, yeah? And then prevalence, you're like, okay, this is something that we know. So somebody who's already been identified to have cancer, okay, now we're gonna sequence that cancer, see what's there. All right, these genes are also present. So you can think about prevalence in that sort of way. But what our lab focuses on is adding an additional metric called effect size, because in those two conditions of themselves, they're a bit static. And so effect size is dynamic in the sense that it says, hey, yes, these things are there. Yes, they're found and they're connected, but what is the actual effect it is having on the cancer? How strong of a driver is it, right? You start to add in a bit more color into what is this driver, you know? So let's go to the next slide. And so, so Dr. Townsend really, you know, this is his lab. And so he's come up with this way to better understand, like, what is our bioinformatic tool actually doing and try to understand it. And so to quantify cancer effect size, prevalence must be deconvolved, right? So you found this gene that's been significant and that is present. How do we understand more details about it? And you can look at mutation rate. And mutation rate means how fast is that that cancer mutating, right? And that's one factor, but there's also an evolutionary factor that we can find out based on evolutionary theory. So in high school, I know you talk about Darwin's theory as well, right? You're thinking about how our, you know, they talk about like the giraffe, you know, is neck is as long as it is because it kept reaching over time for the apple that was high. That's not necessarily the case, right? There were basically initially an array of giraffes that had long and shorter necks, right? And certain ones over time that could reach those apples survived and then were able to procreate. And now you have like this example of that species. So it's the same thing with cancer. You have a cancer that says, hey, you know, there's an array of different things, but then, hey, I'm close to a blood vessel. I'm getting these, you know, angiogenic receptors that are close to me that I can, you know, hop onto and then I can grow, right? Because cancer wants to survive, right? So what happens? A mutation creates a variation, which can happen just through normal sort of reproduction, right? Because cells divide normally. But there could be a mistake that happens, and then that mistake could then become selected. So unfavorable mutations selected against, and then reproduction and mutation occur of that favorable mutation that actually survives, right? Like the giraffes with longer necks, and then they reproduce. So it's the same thing that happens, and now we're just adding in a method to actually detect that and add that resolution. Also, you can substitute that for effect size. So next slide, please. Now it's like take a quick breather. That's all the science. That's what we're talking about. Okay, next slide. So future cancer research, well, how do these things play a role in what we're thinking about today? So with the research we're doing in the lab, cancer effect size, as you can see, is really important, right? And so it plays a role clearly in basic research, precision medicine, because you can sequence an individual and figure out what's happening with that particular genetic landscape. And we're building the algorithm so it's much tighter and stronger, so we can have better resolution to do that for individuals. But obviously it already plays a role in pharmaceutical development. You know, you've got with breast cancer, the BRCA genes, you know, that are really popular. And so there have been targeted therapies against those things that have been developed. And obviously linked to clinical trials. And so the other logo, so that's my company's logo next to clinical trials, because that's some work that we've done. And then with the center that I'm a PI for, we talk about the pharmaceutical development as well. And then clearly the research from the lab. So next slide, please. Next, please. And so these are the quick takeaways. So if you like this trajectory, if you felt that it was interesting, for me, it all started with summer research programs. And I know, Anwita, you've already done that, like none more than I did. So you're probably going to be, you know, a Dr. Rivera with the MD and a PhD, and a me, and a Christine. So you're well suited. But for the other high schoolers looking on, it's critical. I think if you find a research program, no matter like where it is, it could be academic, government, industry, lots of folks have programs. And for me, when I found the Eureka program in Ireland, that wasn't from anybody at Georgia Tech. I just literally Googled it and found it and applied. And look, I just like randomly got, oh, you're welcome, congratulations. So you can just use that as a method to just shoot your shot and see where it lands. And it really may be, you know, a game changer. And then professional organizations, societies as well. So network building, be intentional about developing the relationships you need, both personal and professional. I can't really overstress that enough, that your net worth is your network, like that's a real thing. And so the other thing I'll say is, you know that you don't know everything, and that's okay. Like, you don't have to have a strong ego to kind of mimic what you may feel like somebody of status has. Like, it doesn't really serve them well, really, and it won't serve you well. So it's best to operate with integrity and equity as much as possible. And honestly, you learn so much more that way. I know I do constantly. And so support systems, developing healthy coping mechanisms to deal with stress early. Now that is a real recommendation from me, because that is not something that I did. I was very stressed during a lot of these periods. But now I've been figuring out like how to make sure I incorporate that self-care, you know, that a lot of us talk about, to make sure you can manage all the things you want. And then finding and holding on to your ride or dies. My business partner, Diana, has been one of those. And I definitely was like, we need to go into business together, and convinced her to come back with me. So I think do the same thing with your friends, and honestly, you'll be setting yourself up for success. So, and that's all I have. Thank you guys so much.
Thank you, Dr. Cross, for that amazing and informative presentation. Our final speaker is Christine Hodgdon. Christine Hodgdon was a conservation biologist before her metastatic breast cancer, or MBC, diagnosis in April 2015. Christine serves in an advisory role across multiple healthcare sectors, has completed dozens of research grant reviews, participated in several scientific advocacy trainings, and has testified before the Maryland State Legislature. Her advocacy career began when she launched the stormriders.org, an educational resource for MBC patients that includes a searchable clinical trial database. She later co-founded GRASP, guiding researchers and advocates to scientific partnerships, which empowers patients, clinicians, and researchers to exchange ideas and learn from each other. She spearheaded the MBC Alliance-sponsored Breast Cancer Brain Metastasis, or BCBM initiative, Marina Kaplan Project, with the goal to address the unmet research needs of breast cancer patients living with central nervous system metastasis. She also collaborates with leadership at Johns Hopkins Sidney Kimmel Comprehensive Cancer Center to innovate the INSPIRE, or Influencing Science Through Patient-Informed Research and Education advocacy program. Important to any of the initiatives with which Christine is involved is working to end health disparities and inequities in underserved and vulnerable populations, especially in communities of color that are disproportionately impacted by breast cancer. Her advocacy work is also inspired and driven by the loss of many friends to MBC.
Thanks, Anvita. Can you hear me okay? Make sure I'm okay. I'm going to try to zip through some of these slides. Thank you guys so much. And thanks to the other panelists. This is awesome. I feel like we are going to share a lot of the same kind of lessons learned. I was definitely feeling a lot of what you all were saying. So hopefully this is informative for everybody else. We can go to the next slide. So I have a very windy career, and I totally fell into the oncology world by accident, but science was always kind of a thread, and biology specifically. So I wanted to kind of track where I started and then how I got here. I actually am from Pittsburgh. I went to a great high school. I followed all the AP honors tracks. I decided to major in veterinary medicine. I really love animals, and I didn't really know what else to do. You know, when you love animals, you just become a vet. I didn't really know that there were other careers around that. So I went to NC State University, which is a great vet school. And I actually worked as a vet tech almost for about a decade. And I just really didn't like it. And so I just really encourage you all, like, if you have like a thing that you think you're set on, just, this is how life works. Like, you know, it's not a straight line. You're going to be all over the place. So I was really dead set on being a vet. And then I worked in the hospital and I just hated it. I just did not really enjoy it. I really liked the science. I liked, actually love watching the surgeries, but I just wasn't in it for me. So you can go to the next slide. I ended up doing a internship. I think they called it a co-op. One thing I realized in making this presentation is that I'm a little bit old. So I had to like really go back and like think about all these things that I did. So we did something called a co-op where my last semester, I actually did like a hands-on kind of training experience. So I worked at Moat Marine Lab in Florida with dolphins, whales, and turtles, and just doing rehab. You can go to the next slide. That was also really fun, but I also got basically my career path has been a series of things I don't like. So every time I would try it and then I'd be like, don't like it, moving on to the next thing. So I really encourage people to think about that like, if you feel discouraged, we've all been there, we've all been discouraged, we've all felt like, what am I doing? Why am I here? I always say I give it like a year. And if after a year, I'm still really, really unhappy, I moved to the next thing. So that's why I have so many different experiences. So now you can see I'm feeding tigers and lions, and this is called a binturong. It's from Southeast Asia. This is a carnivore sanctuary that I worked at. So I kind of moved from the wildlife rehab to still kind of rehabilitation, but mostly just like caretaking, like basically like a zookeeper. And again, I got kind of bored. So I was just like, yep, nope, this isn't it either. Like, it was great. I worked outside all the time. I was like the fittest I've ever been, but it just wasn't really like exciting me. And I really wanted to be passionate about what I was doing. So I ended up getting another internship. You can go to the next slide. So I just kept trying different things. I was like, all right, let me apply for this internship. This is actually at the National Zoo in Washington, D.C. These are golden lion tamarins. They're an endangered primate from Brazil. And this was actually where I was exposed to what conservation was. So this was a pretty cool, I'm pretty sure this still exists at the zoo if you ever go. These monkeys are free ranging. They roam around the zoo. And the idea is to kind of simulate like a natural environment and then reintroduce them into the wild in the Atlantic forest in Brazil. It's a very successful reintroduction program. It was really cool. I got really excited. I felt like, okay, this is like igniting something inside of me. I didn't really like the hands-on vet tech stuff. I didn't love the animal rehab, didn't love the zookeeping, but this is something a little bit broader where I'm like working towards maybe protecting habitat, but I really love the idea of protecting endangered species. So I learned about a program at the University of Maryland. You can go to the next slide. At College Park, and it was a conservation biology and sustainable development program. And my thesis was, it's not important. By the way, none of the stuff that I studied am I doing anything with now. So I'm going to just kind of zip through. That also happens a lot. When you don't follow that straight line, a lot of what you learn doesn't matter later. But all the experiences do matter because it really does help shape what you end up becoming and what you want to do. So this is me presenting some of my work. I helped launch a nonprofit focused on human wildlife conflict all over the world, actually, but a lot in Africa. And I'm actually in South Africa presenting this poster. And I graduated in 2007. And you can go to the next slide because I can't remember what I did next in my life. Oh, okay. This is just pictures of what I love photography. One of the things I always tell people is that you should definitely travel. Like, this is definitely, I think Dr. Cross mentioned studying abroad. Huge impact. I mean, you will learn so much, and I think it just opens you up. It's really good to put yourself out of your comfort zone. Like, I always just try to find ways to be out of my element, and that really is just like good life lessons. And so I really encourage travel. You can go to the next slide. I've been to lots of countries at this point. These are all the different places I've been to, but I think I'm almost to 40 countries at this point. So I really encourage travel. That's just good life advice. So I hope you guys take that. If you can study abroad, do it. If you can travel, like I've done a lot of summer internship programs. I did one in Kenya. It's just a really great experience. You'll learn a lot. And I did study abroad in Australia, and oh my God, it was like so much harder than the US education system. Like it's a totally different ball game. Like I almost failed some of my classes because it was so hard. So it's just good to challenge yourself. You can go to the next slide. Oh yeah, just me showing off my photography. Go on, you can go to the next slide. Okay, so around the end of my 20s, I eventually ended up in DC working at another nonprofit, this time in like ocean conservation. So I just kept like bouncing around to different places. And I'll be really honest, I lost my father in 2009 to a rare type of cancer. And it just sort of, it just struck me that life is short and I should just not waste time, and I should really get going on things that I want to do with my life. And I wasn't really happy in my job, and I always wanted to learn another language, and I'd always wanted to do Peace Corps, and I always talked about it and I never did it. And then I finally just said, I'm doing it. So this is actually me in Guatemala. So from 2011 to 2013, I served as a Peace Corps volunteer. Again, I had a windy path there too. I actually was pulled out of my first site due to security reasons. So I was actually managing a bird reserve. And in this first photo, I'm actually doing some water sampling near a lake that I lived on that was surrounded by volcanoes. It was very beautiful. Another really amazing travel experience. Peace Corps is also awesome. I could highly recommend. And it really caters to all different types of people, like whatever you're interested in. I ended up being a ecotourism volunteer, but I still ended up doing a lot of sciencey stuff. So it was great. You can go to the next slide. And when I came back, I actually finally landed my first real job in conservation at a organization called Rainforest Trust. And I worked with a bunch of ornithologists. That's why I have all these bird pictures. So again, I myself was not really, I worked with a lot of people that had PhDs. I had my master's, but I found that I just wasn't really that excited about it. Like I was doing a lot of the program management, a lot of the admin stuff, and it just wasn't really getting me going. I just kind of felt like, yeah, I don't know if this is making me that happy. And I would watch everybody around me, and you can see when people are like really passionate about something, it's very obvious. It's like really obvious of people who love what they're doing. And so I just encourage you, like, if you're not feeling that, try to find it. Like, just keep going. I think Dr. Cross said that too, like persistence, and just keep trying, keep failing, keep going, because you will eventually fall into it. And I do think that finding mentors is really helpful as well. And what happened was, while I was actually working at this job, you can go to the next slide, I actually got diagnosed with breast cancer at the age of 34. So it was completely unexpected. I have no history in my family. I was too young to be getting mammograms. So I basically found 2 lumps myself in my right breast. I went and ended up, I actually had a doctor who ignored me for about 8 months, telling me that, you know, it was nothing to worry about and everything would be fine. And then finally, he ended up doing a biopsy, and it was determined that I did indeed have breast cancer. We had to do a PET scan to then stage me, and we found that the breast cancer had actually already spread to my lung. So I had lung metastasis, which means that was stage 4 metastatic, which is actually a pretty bad prognosis. I happen to have a subtype that responds really well to treatments. So I'm actually doing really well now. I have no evidence of disease, but at the time it was terrifying. And I actually am very, very lucky. As Anvita mentioned in that bio, I've lost many, many friends to metastatic breast cancer. But at this time, I really was just trying to focus on like staying alive, getting through my treatments. I continued working full time. I did everything. I did, you know, chemotherapy for 4 months. Oh, you can go to the next slide. I can't remember what comes next. Okay, so I did chemotherapy, surgery, radiation. It takes like a year really of stuff. Like you're just dealing with a lot of stuff when you get diagnosed, especially when you're metastatic. And so I was really just focused on taking care of myself, continuing to work. I did eventually quit my job because I just really couldn't handle. I mean, I get infusions. I actually had an infusion this morning. I still have a port in my chest. So I get targeted treatments every 3 weeks. I'm on hormone therapy. So I have a lot of side effects. I think I manage them pretty well, but it was really hard to work full time and deal with deal with this disease. And so I did end up quitting, thinking I'd eventually go back into conservation. And actually I just kind of fell into advocacy. I just started, I started meeting, I went to conferences. I was really interested in the research and the science behind cancer. And I was really nervous about if I did have progression, even though I was stable, I was worried, like, what is the next drug I'll be on? What's another trial that I could do if I did have progression? So these are just a few pictures. Again, I'm like bragging a little bit. That's me with Michael Strahan. I was on Good Morning America. So these are some of my friends. And the woman pictured here with the funny shirt, my oncologist does my hair, was a dear friend of mine that I actually lost in August of 2019. And she was very special. She was a really hardcore advocate. And she actually had the exact same type of breast cancer that I did, the same subtype and everything. And it just goes to show you, like, we still don't know that much about metastatic disease. And we really don't know, like, why did she not respond and why did I respond? You know, we just don't really know. You can go to the next slide. So through, you know, all this work, I did some of these campaigns where I talked about metastatic breast cancer. I was really struck by Dr. Cross's, your intro about, you know, being the only Black man, only Black face at a lot of these events. So for me, I saw a lot of white people, but I didn't see anybody my age. That was like a really big problem, is that I was always walking in and I was the youngest person, and there's people like upset about how they may never get to meet their grandchildren. And I was like, I can't even have children. I might not even, you know, like, I don't even know if I'm going to make it, you know, another year. And, you know, I haven't gotten married. I haven't done all the, you know, there was just a lot of things I wanted to do in my life. So, what I did a lot more like awareness and education, but then I got really interested. As I mentioned, I started going to conferences and learning about the science. I created my own database of clinical trials. And this is I think you both mentioned that you had like a partner in crime. Julia Malice is mine. She's my work wife. She's also a metastatic patient. And she and I co-founded this program called GRASP, Guiding Researchers and Advocates to Scientific Partnerships. And the real reason why is because we see that patients are often siloed from clinicians, from researchers. And we really feel that, like, we bring an expertise that a doctor or a researcher can't bring, that we have an expertise in living with cancer. We always say that, you know, there's researchers are studying cancer, oncologists are experts in treating it, but we're experts in living with it. So we created this program because we realized that there were just not that many opportunities for researchers to meet advocates. It's a little bit different for clinicians. They can see patients on a regular basis, but people who are in a lab, oftentimes they're doing like decades of work and they've like never had a chance to actually talk to somebody with the disease that they might be studying. So, and I encourage everybody to go to this website. You all can register. You would just sign, it's just a free membership. And we're kind of creating like a database of advocates and researchers. And so what we do is we will often have, if researchers are looking for a particular advocate that they want to, you know, pick their brain about something, maybe they're submitting a grant and they want to know more about what the patient perspective is, we'll hold little focus groups like that. But our big bread and butter is where we do all the conferences. So you can go to the next slide. So we just had a really big conference, the ASCO conference, where it's the clinical oncology, it's the biggest cancer conference that there is. And we were one of the official patient advocacy programs there. And so what we did was we pulled together these small groups and we do almost like a poster walkthrough, like a scientific poster walkthrough. So it's all virtual now. We only did one in person and then we had to kind of move to the virtual setting. But the idea behind this is to create these like intimate groups where you have one scientist, you have one experienced patient advocate, and then you have maybe 2 to 3 other patient advocates or caregivers. As long as, you know, we use that term loosely. You don't have to have been a survivor to be an advocate. You just have to care about it. And we usually only do about 2 posters per group. But what we're really doing, it's funny because a lot of people think like, how many posters do I need to get done? We're like, it's not about the posters, it's about the conversation and the engagement. And what we're really trying to do is we're trying to kind of level that playing field. A lot of times you'll see a webinar where you have a scientist, one scientist and like 20 advocates or 20 patients, and they're all listening to what the scientist says, and the scientist doesn't really get to hear anything from the advocates. So we tried to kind of level that out. We have just a very small group, and what we do is we really encourage advocates to share their story and share their experiences and interrupt the scientist and say, like, I don't understand what you mean by that. Can you explain it? So it's really unique. I haven't really seen it anywhere else. And I think the difference is that this is a patient-led program. It's like for patients by patients. You can go to the next slide. So we serve researchers, including clinicians and scientists, advocates, patients, and caregivers. You can go to the next slide. And this is our philosophy. It's all about bidirectional learning. We've noticed that it really does help scientists. It really hones their communication skills. A lot of times when we walk up to a poster and we ask them, like, you know, tell us about your research, one of the first questions I see a lot of advocates ask is why? Why are you doing that? Why are you studying it? And it's funny because you'll see people like stumbling over their words because it's like, I don't know. I thought it was a cool protein that I wanted to study. And it's like, okay, but how is it going to impact me? And so the patients really bring it home for you. Or it's like, why, you know, this is great. Maybe it's really cool and really interesting science, but how is it actually going to help patients? So we really believe that patients can bring that value to research. And it helps patients too. It gives us hope to know about the research that's going on. You go to the next slide. So this is our vision. And actually I love this picture because the woman that's presenting that poster, she's like the head of the OSU breast cancer department, and she actually is living with metastatic breast cancer. And she's a phenomenal woman. She has like the best trainees. She's actually sent a lot of people our way. We have a really good relationship with OSU now. And she's just a wonderful person. And I'm very grateful that she shared that with us, that she actually is living with metastatic disease. It really makes a difference. But we are hoping to create a shift towards a more patient inclusive research paradigm. And we think we can just we think that we can drive more impactful research and more fundable research. So that's what I always tell scientists who are kind of like on the fence about us. I'm like, I can get you funded. I've gotten lots of people funded just from giving my perspective, and it's very valuable. So that helps a little bit. Once they get involved, I think they don't really need to be convinced. Once they actually start working with patients, they see the value. You can go to the next slide. So we piloted at San Antonio, which is the San Antonio Breast Cancer Symposium. We thought we were going to have 12 participants. It ended up being actually well over 195 individuals. We had a lot of repeats. And we actually received a donation without even trying. We weren't really trying to be anything. We just thought this was a cool idea. And with that donation, I care very deeply about health inequity and health disparities. And in breast cancer, Black women are actually 40% more likely to die of breast cancer. And so we really wanted to do something. You know, I'm a white woman, I have privilege. I wanted to use that privilege and do something to actually move the needle a little bit. And one of the things we see is that a lot of times at these conferences, we see the same people, and they're usually older and they're retired and they're usually white. And so one of the things we thought we could do with this donation is we could actually elevate the status of Black women, make sure that they're more represented at this conference. And we sent 11 African-American patient advocates. Most of them, I think almost all of them, were survivors, some early stage, some metastatic, and they participated in GRASP, and it was awesome. I don't know what else to say. It was just like an amazing experience. We were really happy with how it turned out. It went well beyond our expectations. You can go to the next slide. That was just our first, I'm just giving a few statistics here, but so this is actually outdated because we just had ASCO, and that was our largest GRASP to date. But this one at San Antonio, we had 141 participants. We had 38 different groups. You can see the breakdown here. We're trying to capture that information about race and ethnicity. So we're very, we work really hard to make sure that we're not just recruiting advocates of color, but we want to see scientists, researchers, clinicians of color as well. That's also important. So I'll have to update this slide with our ASCO statistics. You can go to the next slide. So if you're interested in participating in GRASP, again, a little bit outdated here, but we just had ASCO, but we'll have another conference. We'll be at Teresa's Research, which is focused on metastatic breast cancer only. Then there's a Congress of the Metastasis, the Biennial Congress of the Metastasis Research Society. That'll be in November. And we actually, I think we're actually going to do something with the World Lung Cancer Conference. We've branched out now beyond breast cancer. ASCO covers all cancers. It's not just breast. So we had lots of different representation from, I think, like 6 different cancer groups. So we actually would love to see this replicated at every conference that involves patients. It just doesn't make sense to me that that there's a conference ongoing that has research that, you wouldn't have without patients, you wouldn't have that data or that research. So it's weird to not have the patients at the table. So we hope to see this in lots of other places, not just breast cancer. And you can go ahead to the next slide. That's it, I think. So yeah, check us out on the website.
Thank you, Christine, for your amazing presentation. And thank you to all the speakers for taking the time to be here today. It was really interesting to hear your unique experiences. And I definitely learned a lot about the various aspects of cancer. And I hope everyone watching did too. Now we're going to move on to a quick Q&A session. So these questions are directed to all of the speakers, any and all. And the first one I wanted to ask is one that I feel a lot of people have when thinking about cancer, and that's, why is there no universal cure for cancer yet? And why are some cancers more treatable or preventable than others?
I think maybe as a researcher, I could take the first stab at trying to answer that. So the question is, why is there basically no cure yet, even though there's been trillions of dollars spent in the industry? And the reality is, it's much more complex than people thought it was, right? And it's much more evasive than people thought it was as well. And there, even on my slides where I talked about the driver genes, there are hundreds of driver's genes, if not thousands. And so if you think about it, initially folks were like, hey, it's something to do with the division factor, cell division, and then we can figure it out with those. But oh, it's not just those. So cancer starts, from one mutation, and then it builds, right? And so it finds these friends that it needs to continue to grow and to survive, and it mutates. So what happens is, even when we find a really effective treatment, it also adapts to that. And so it can then reroute itself and find another mechanism to continue to grow and metastasize. So the reality is, it's just much more difficult than we ever thought it was. But the reality is, we are getting better at finding those pathways that it's more likely to take. But we aren't there yet. But we're getting there with the advent of, because first, we didn't have sequencing, right? So that's really about a decade and a half ago. We really just got next generation sequencing. And then we were getting more targeted therapies, which we didn't really have before. And now we're getting into machine learning and artificial intelligence to actually process all of that big data that we can get from sequencing. And so that's where the work that I'm doing in the lab now is coming in, and even the blood test with the startup in California, that's exactly what they're using. They're using artificial intelligence and machine learning in order to actually track the biomarkers, understand there's multiple biomarkers to ultimately diagnose cancer early. And that's where the field is at large, is focused on early cancer detection, which results in cancer prevention. So that's where majority of the efforts are. Unfortunately, to Christine's point, metastasized cancer is even more difficult, right? Because that's the stage at which cancer is already fully developed, and then all of those compensatory mechanisms are already in place, which makes it just more difficult to treat. So hopefully that provides some insight to your answer to your question.
I would just add, I mean, I don't think there's much to add to Dr. Cross' answer. I think, as you said, even metastatic cancer and some forms of less aggressive cancer like prostate cancer, we have learned a lot. And therapies, these are now chronic illness, such as like, you know, living with heart disease right, for some cancers within the spectrum. And regarding therapy, you know, as Dr. Cross nicely highlighted, right, cancer evolves and it becomes resistant to the different weapons that I described, right, the different therapies that we give. And we've learned as well that it's not only about the cancer, but the cells that are surrounding the cancer and our immune system, right? The cancer develops the ability to kind of hide from the immune system and preventing our immune system from killing it. So that's a whole new world of immunotherapy and understanding kind of the inflammatory cells that live around tumors and how they affect tumor and how they kind of evade the system and respond to therapy. So it's complex. I think we're learning a lot, and certainly the fields and therapies are improving outcomes.
I was just going to add that somebody gave me the analogy of like HIV versus cancer. And HIV is just like one, it's like one virus, like that's it. And so cancer, even within breast cancer, we have like 30 different types and it presents differently. Like even just within breast cancer, it is so unique to each patient. And so you hear a lot about personalized medicine. That's becoming more and more common. But it's very difficult. Every once in a while, you'll find like for me, I think I have like the miracle drug, which is Herceptin. My cancer expressed HER2. It's a HER2 protein. And it is just one of these like amazing biomarkers that like, if you can target it, if it responds, you're going to be okay. And that, 20 years ago, it was a very aggressive death sentence type of cancer. And so, I just give that example so that people still are encouraged. So like, we really do need more research. We need more cancer researchers. We need to get more information, but it is just such a unique, it is so unique in each person. And that's part of the complexity.
Thank you all for those informative answers. And for the next and final question, how can everyday people who are not as heavily involved with cancer study help with the efforts to tackle cancer?
That's a hard question. Well, they can join GRASP. That's one thing I would say. Just do that. It's a really easy way to, I mean, what's really cool is I get like world-renowned researchers involved. And so it gives you a chance to be in like a small breakout group with maybe somebody who discovered like a mutation that is very impactful now. So, you know, that is one way. Anwita, the reason why I'm here is because Anwita actually took this initiative to ask an FDA oncologist if she knew any cancer patients, and said, hey, I'd love to, you know, we'd love to work with a cancer patient. I think then it was in terms of like supporting a cancer patient. And I responded and said, oh, you can support me. It's not the way you think it's going to be, but I review all these research articles and I really need help like reviewing them and categorizing them. And I would love your input. And so now we just do like a very informal weekly research review with like six other women, and it's great. So like you can be creative. You know, I think there's a lot of different ways, but I'm sure there's more. I can't think of any others at this point. Hopefully the other panelists have some ideas.
Oh, you gonna go first, Dr. Rivera?
No, I think, I mean, at least from my standpoint, the education is a big responsibility for me when I'm talking to patients. I think my time with the patient is like the most sacred thing for me, and making the patient, and not only the patient, the family members around them, understand what we're doing and what we're doing is the most important thing. And I think even then, how much we can do within the time frame of a consultation is so limited, which I think, grasp all these other tools that we have available to kind of further, deepen and simplify and bring another perspective is what I usually, guide patients. And I'll be guiding my patients to grasp. I feel like, there are different foundations have, for example, one that comes to mind, the Prostate Cancer Foundation has, patients who have summarized big clinical trials and have put it into words that are easy to understand to people. We have to empower patients and make them also responsible for learning more about, their disease and to ask and question, their physicians and I think that's the most important thing that we have to, or me as a physician have to try to get across. But you're right, there's a lot of work to do, and we need more help.
Yeah, I think to your question around what can the average person do to be involved with cancer, it makes me think about who do I know who's been affected by cancer, right? And I think really we all know someone who's probably in our family, right, or in our tribe that we are really close with. I think what an everyday person could do is engage that person in conversation and try to understand what it is they may be going through. And I think having that conversation with that individual and opening yourself to their reality would be really helpful. And then using that to support, that individual, that cancer, through a walk, through research, through, any number of ways that individual feels empowered to do that. But I think having the conversation with folks who've been affected by it would be a great start, for somebody who may not be, biologically inclined.
Thank you for the informative responses. And again, thank you to all the panelists for being here today. It was really interesting to hear all the presentations, and I think it's going to be really helpful for young women who are interested in learning more about cancer and joining the efforts to tackle this disease. And to wrap up the event, I'm going to hand it back to Ms. Shravani.
Thank you, Anvita, and thank you again to all our speakers. I've been out of high school for a while, but even I thought your stories were inspiring. Your presentations were so interesting, and I learned a lot as well. So thank you again, and I'm sure our Young Women in Bio members would really enjoy this event. Thank you.